So now I am going to start our class. So far we are now on class number, lecture number 6, only for memory purpose. Now today I will discuss about the typical real-time system. What is the typical real-time system and how will it work? Now in this diagram we can see here how various sensors are connected with the operating environment to the controlling system. So how will we control various devices with the help of the operating system to implement the real-time system? So in this case, you can see the operating environment and the controlling system, how they have connectivity, or we can say the interface. In this case, you can see there are various sensors connected and also the actuator. So inside the black box, you can see here, these are the electronic devices. You are already aware, maybe aware by the actuators and sensors. Actuators control the signals and give the better frequency and give better signal, and sensors senses the various signals or information and report it to the controlling system so that we can control the various devices what is going on with the help of the operating system. So this is the basic block diagram to implement the real-time system. So real-time system is what which gives the immediate response. Whenever you are going to click anything and as a output, you will get immediate response. So such type of systems are called the real-time systems. So real-time systems we can use anywhere. There are number of applications in today's time. We can control each and everything with the help of the real-time system. So one of the better, we can say the good example, suppose we want to control the frequency. Okay, in India we are using the frequency as 50 hertz and it remains under control. We cannot change or vary the frequency. Okay, so this is the fixed one, and with the help of the real-time system we are going to control this, and we can see if there is a little bit drop either in the frequency or in the voltage, then we will get the signal with the help of the sensors, and then we can do physically with the help of other electronic devices, we can maintain point wise frequency as well as the voltage or current. Similarly, we can see in case of the various powerhouses, okay, in which we are going to generate the electricity, either it is the hydroelectric power station or the nuclear power stations, then we use sort of real-time systems, okay, so that we can control various data related to the voltage, frequency, current, etc. Okay, so these are the time based, give the immediate response. Sometimes we can use, if there is a problem of the fire hazards, then we can also use sort of real-time systems. And also in case of the space organization, we are using such type of real-time systems, okay, to get the immediate response. Now there are other, here you can see in this image, these are the various applications, and we can use in the nuclear reactors and also nuclear power plants. And traffic control system, it is one of the best example. We are using the real-time systems, okay, and it is based on the time, as we will set the time of 1 minute or 2 minutes. Some areas are, very much busy areas and lot of traffic. Then we can set the sensors as well as other timers, other controlling devices for the 2 minutes, and then the light becomes red and then change to green after 2 minutes, or some uh, where we can also use set the time in the timer as a 1 minute. Okay, so such type of we can say applications are based on the real time systems. So this have the interface with the real time systems. Now another applications we can see, currently we are using industrial internet or the internet of things. One of the major topic we are working on that, that is called the internet of things. Okay, so here you can see in this diagram, so just we have chosen various images so that you can understand easily. Now the internet of things, here you can see anywhere we can use this. Okay, and here anybody can use this, any network we can use at any time, any device, okay, any service. So any device, any service, anytime, any network, anybody, anywhere, it means it is based on the internet. Okay, then it is called the internet of things, because whole working process is based on the internet, that is the connectivity. Okay, so if we have the internet facility, then we can use this industrial internet. Or in the second diagram you can see here, there are a number of devices which have the connectivity with the server. Okay, and along with this we are also gathering or collecting the database. Now in this diagram you can see you have the home here, and there are several devices which are connected with this. Okay, now you can see everything is connected, bell or the speakers, or we can see the lighting system or computer system, and we have the hub also, and it has the connectivity with other here the server which we are using from the remote places, and this is the database. We can retrieve the data or we can store there. This is the load balancer, replicas, etc. It balances the load. If there are a number of users which are using the server, then the load balancer will balance the load. Okay. Here you can see this server also have the connectivity with the other systems, the electronic gadget. Here you can see laptops or the TV technology, and other you can see mobile cameras, etc. Okay, video cameras, etc. Now we can use this. So each and everything have the connectivity with the server with the help of the internet. Okay, so this is the technology currently we are using, internet of things. So how we are going to connect with the real-time systems? Only with the help of the networking, okay, internet. So this is, we can say, the major backbone for the current devices, okay, or how we are using the real-time systems, then it will also depend on the internet. Now, this is the basic introduction for the real-time system. After you have already seen a number of images, how it provides the connectivity with the real-time systems. So, real-time systems are defined the systems in which correctness of the system depends not only on the logical result. So, here we are not going uh, to emphasize on the logical result of computation, but also on the time. So here we want to see a number of results, but we also concentrate over the time. In how much time we are getting the response. Okay, so the the time is the, we can say, the major role player. Okay, so in how much time we will finish uh, our task. Okay, and after how much time we'll get the response, get back the response. So at which the results are produced. So we will also wait for the results which will be produced after the working on that system. Okay, so this is the time-based technology, and using the real-time systems, it will depends on the logical result as well as the time. So time is very important. We can say the, what vital role of the time here. Now the hard real-time systems we are using currently, the real-time system, avionics, and command and control systems. So everywhere we are using, okay, whether this is a case of the defense, air force, army, everywhere we are using, and these are uh, also based on the command and control systems. So wherever we are using some sort of control systems, then there is a big role of the real-time systems. Similarly, firm real-time systems, firm means there is a very major role. Currently, we are using in the banking, online transaction processing. So, firm real-time systems. Okay, but everything is based on the Internet of Things. We have no internet, we have no connectivity, we have no network system. Okay, then we cannot use the online system, will die out, will finish. Okay, so the main backbone is the internet of things. Everything, if we will use the online system, okay, whether it is we are using the real time system or other. So just I am discussing about the real time systems, and this is the basic introduction. Okay, so real time, just we will see and count 2 points. We will concentrate over the two factors. First is called the logical result, and another is a very important factor is called the time. Okay, so the time at which the results are produced. So we will wait for the results. Okay, that is very important. That is the working of the real-time systems means will depend only on the time. Okay, after how much time we will get the response. So that's why these are called the real-time systems. Now there are we are discussing here from real-time systems. Okay, so from real-time systems we are currently using in the banking system, online transaction processing, everywhere. Okay, but everything will depend on the networking, internet of things. Uh, so third one is the soft real-time systems. So first is the hard real-time systems. The examples are the defense. Okay, avionics. Uh, we are using command and control systems. Now everything is based on the control systems. Either we can take the examples of the different powerhouses or other. There are various companies which are working based on the control systems and using several electronic devices. Okay, whether it is electronic devices and in each and every field we are using the various electronic device and has the interface with the other engineering line. whether it is a mechanical or the electrical engineering, but we are using as a interface various electronic devices. But above all, we are there. Okay, means everything depending on the computer system, internet. So that is the hard real-time systems. Now you can see. Second is the firm real-time systems, banking system, online transaction, soft real-time systems, video streaming. Now we have the connectivity. We are, currently using various videos or the audios we can see here. But online we are working on that. Okay, if we have the net facility, then we can use the video streaming as well. So such type of is called the soft real-time systems. So this is the classification for the real-time systems here. Now we can see here example. Just we are considering one example of the car driver. So what is the mission of that? Reaching the destination safely. Okay. So what is the mission of the car driver? Reaching the destination safely. Okay. Control system. What is the control system? Here we are using the car. Okay. Because this is purely based on the mechanical system. Nowadays we are using various electronic devices there for and sensors also. Okay. Because this is today's car based on the high technology, high tech. High tech means we are using various electronic sensors as well as the computer system for controlling, and involving very much firmware there. Okay, so chip based. Now you can see the control system here is the car operating environment, road conditions. Okay, now because you are using several apps on the Android phone, and with the help of the mobile and the internet, you can no need to search the way where or we can say the destination wherever you are going. So you will get each and every information regarding the road conditions as well as the direction as well as the destination and other related we can say the data. Okay, so each and every thing we can retrieve the information, but the backbone is the again the internet. Okay, so controlling system here we can compare human driver. Okay, so these are based on the sensors. Human driver using now the sensors, eyes, ears of the driver. So sensors क्या क्या है आपके पास? Now you can see here eyes and the ears of the driver. These are the we can say the natural sensors. Now the computer sensor here we can see in the context of the computer, the sensors are cameras, infrared receiver, laser telemeter, navigation system, street maps. Okay. Now we have a lot of the apps and we can use. So these acts as sensors in context of the computer technology. Okay. But earlier the natural we can say the sensors we were using or currently again using. Currently we are using the same eyes and ears of the driver, and including that we are using the computer latest technology that is based on the internet. Okay, so the sensors just we have already discussed here, and you are already aware by each and every here devices. Okay, in the form of the softwares or the apps. Apps are nothing but the softwares different which are developed by you people. Okay. Now the we can see here the controls. Controls kya hai? What are the different controls? Accelerator, steering wheel, brake pedal. Okay. So accelerator and steering wheel and pedals. Here we can use for the brake, so brake pedal and steering wheel for changing the direction wherever we want to go, and accelerator to enhance the speed. So we are controlling this. Okay, actuators. Now actuators here we can use as these are the signal systems in the context of the electronic devices, but here the wheels, okay, the engines and brakes, actuators in the hard form, we can say. Okay, we are currently using the wheels, engines, and brakes. Now, currently we are using the various, the operating environment, okay, controlling systems. Now, our car or the based on the high technology and completely, you can say, have the interface with the internet as well as various, computer equipped with the computer technology. Now, a critical task, what are the critical tasks? Or typical that we can face the problem that the steering and the braking. Okay. Suppose sometimes if the steering will not work or sometimes the brake fails, then these are the critical tasks. Okay. It is very difficult to control over that. Now, non-critical task here, we are comparing the things. Now, non-critical task here, turning on radio. Okay. Now we are using several apps, so we can use and we can protect somewhat with the help of that. Performance is not an absolute one. It measures the goodness of the outcome relative to the best outcome possible under a given circumstance. So uh, the performance is not absolute one. It's still because we are still designing and equipping with the high technology, and sometimes maybe due to the signal failure or we can say the overloading on the internet, then some problem may come, and again we will come over the natural, you can say the tools, okay, or the natural sensors. So still we are waiting for the ideal performance, even though it is very much updated and improved. Next is the cost of fulfilling the mission. So cost of fulfilling the mission, here efficient solution. So what is the cost we are going to pay for that? Our mission is efficient solution. So there must be the solution for that efficient. Okay, so that we can feel comfortable and equipped with the high technology. We can enjoy our life. Another thing is the reliability of the driver. So what is the reliability of the driver? Fault tolerance is a must. So what is the role of the driver? He protects you against various faults, okay, means accidents. Nowadays, due to the high technology, we are aware, we are using several softwares or the apps so that we can protect before that. But before the God, we are nothing. Okay. Just we are promoting ourselves toward the high technology. We are interfacing, we are equipping with the high technology. But we cannot say we are in the reliable mode. Okay. So we cannot take the guarantee of the reliability, even though just we are trying. But there is a, you can say, the end of everything. We are trying to do good, but everything in the hands of the God. So the task constraints, here you can see deadline constraints are the resource constraints. Resource constraints got shared access. Read here is given. We can share the several, the task, exclusive access, write access. So these are the various tasks which constraints which we will write or use them whenever we are designing the different softwares. Precedence constraints T1, T2, these are the various tasks. And during the designing, because just we are concentrating over the operating system, then whenever we will write the system software, mainly the operating system, then we will take care of such things. Okay, whether we are using the other systems or the multi-processor system, multitasking, multi-programming, or the real-time systems, but there is a major role of the operating system here, and we will inbuilt each and every aspects there. Okay, we will design each and every thing whenever we will write the operating system or the system software. Now here you can see the precedence constraints T1, T2. There are different tasks. Task T2 can start executing only after T1 finishes its execution. So here you can see there are if we are working on the two tasks, then if first one will finish, then we will start the another one T2. So it is there are several tasks. We are not finishing or starting manually, but the operating system controlling each and everything. Fault tolerant requirements to achieve higher reliability for task as execution. Reliability means we will protect against the failure of the system. Okay, we will design the operating system in such a way that we can work easily on that and execute perfectly each and every program or the task or the process. Okay, so we will take care during the design of the operating system. Redundancy in execution, sometimes the redundancy may occur during the execution. If there are several tasks you are running, then you can feel such sort of redundancy, or you can achieve or get the redundancy during the execution. Then the operating system will protect or separate the various tasks during the execution time. Okay, and reduce the redundancy. So common misconceptions you can see here. Real-time computing is equivalent to fast computing. So real-time computing, if we are using the real-time system, then is equivalent to fast computing. Okay. So fast computing, whenever we will use the real-time system or there is an involvement of the real-time system, means the fast computing, because this is based on the time constant. Okay, within few microsecond or millisecond or nanosecond, we want the response of that particular system. So the real-time systems are based on the we can say the time constants or the time conditions. So along with this, we will use the other electronic devices to work with the real-time systems. Okay, because we want to control various organization or the companies or the good we can say the major generating stations or frequency or voltage or avionics, or in case of the defense, each and everywhere we are using. So real-time programming is assembly. So whenever we will do sort of programming for the real-time system, then you can see assembly coding we will use, priority interrupt programming, and writing device drivers. Okay, so device drivers mostly written in the form of the assembly language. We use the assembly language, okay, to write such type of real-time system programming. So real-time systems operate in a static environment. Okay, it works in a static environment. Now the problems in real-time system design have all been solved in other areas of computer science. So problems we can in real-time system design we can use in other area of the computer science. So it is not only dedicated to the computer engineering sites or the electronics engineering side, or to control the various electrical engineering and we can say the mechanical systems, but we can also solve various problems for the computer science. Okay, so there is a big role of the computer engineers. Now, what is the operating system structure? Here we will emphasize what will be the structure for the operating system. So there are various factors. Here we can see system components. So the number one is the system components. So we will talk about this system calls. Okay, how we will get the response. Okay, how the signal will go to control other devices. Then it will depend on the system calls. How components fit together. So there are number of components which are connected together then how those components fit together, or they are connected, or how they will provide the interfacing with some other components. And fourth one is the virtual machine. Okay, so we know that operating system will also act as a virtual machine, because over the hardware, okay, we will use the operating system as a magic, and then we will work on other softwares. Okay, we will not work on the uh, we can say the operating system uh, machine. Okay, if we have the hardware, and on that we will install the operating system. So we cannot work directly on the operating system, but we will use the operating system as a platform. So on that platform, we can work on other softwares. Okay, so with the help of the this virtual machine. So operating system, there are various system components. Now the point number one, these are the pieces of system we will be looking at. Now we have already discussed such type of the system components: process management, main memory management, file management, IO system management. Okay, so these are the very important management which will be controlled uh, by the operating system. And other management you can see here: secondary management and networking protection system, command interpreter system. These are the other, you can say, the other things here. But the main management, the above four, you can see, is starting four: process management, main memory management, file management, IO system management. Okay. Now the process management, what is this? A process is a program in execution. So you are already aware by the process. What is the process? How will we define the process? Okay. So we are writing any program, then it is called the passive. Whenever we will run that program, then it comes in the active mode. Then it is called the process. So a process is a program in execution. So after writing, we will compile, and after that we will execute that program. So under execution, it became process. So a program is nothing but a passive. A process is active. So this is the difference between the process and the program. Okay. Anybody can ask what is the difference between the program and the process. So don't say like this set of instruction and process is this. So this is the proper definition here. You can see a process is a program in execution. So process is itself a program. Okay, but a program is passive. Whenever you are going to write the codes, then it is called the program. Whenever it will run, okay, then it became process. So a process has resources. Of course, whenever we will write the program, and it as it will go under execution, then it will use the CPU time as well as the file, where we will you can say save our file. So the a process has resources, may use CPU time and file, and attributes that must be managed. So there are various other attributes which will be managed by the operating system. Okay, so management of process includes, now you can see here, process scheduling means during the process scheduling you will provide the priority. Okay, if there are number of programs are running, then we will provide the priority. Okay, and we will also manage the time. Now I am taking the attendance of first. This is the important part. Only 10 students there, because Zoom time is going to finish. So please, if any question, there was some disturbance due to the network issue. So I will continue in my next class after a gap of one class. Okay. So if any question, please, up to here. Just I am going. The time is of the Zoom is going to finish. Please.
वो सर रिपोर्ट्स चेक नहीं करेंगे सर अभी आप?
हाँ अभी
वरना वो फिर
प्रॉब्लम आ रही कुछ
दूसरा सबमिट करने के लिए अनसबमिट करना पड़ेगा।
अच्छा चलिए देखते हैं, चेक कर देंगे,
क्लासरूम का सिस्टम।
चेक कर देंगे।
ठीक।
हाँ और कोई प्रॉब्लम बताओ। क्लास कैसे कम कर रहे हैं भाई।